a month since the school year started, but despite we struggle a lot adjusting to this new learning system, congratulations, we survived the first month. So for today's video, we will learn Chapter 8 titled Do Dice Play God by Nature's Numbers. So sit back and watch this video.
Hello everyone, so today we are going to talk about a book. It's the Nature's Numbers book, so specifically we are going to talk about the Chapter 8, which also entitles as Do Dice Play God. So the author of this book is Ian Stewart. So a little background of Ian Stewart. He is an emeritus professor. He divides his time equally between research into nonlinear dynamics. Okay, so under his work is Nature's Numbers, which is the annual reality of mathematics. So the book is illustrated with diagrams and graphs of mathematical concepts. Okay, so in this chapter, Albert Einstein shows also how he believed that God does not play dice with the universe, and that the world in which we live in is governed by precise law rather than by chance. Ian Stewart began challenging Isaac Newton and Perry Simon Lutley's vision of a totally deterministic world. So he illustrated that the initial state of its system can never be perfectly measured, and that the difference to what to consider a phoretic texture or the hand of a ladyluck is stated in this chapter. Now, Ian Stewart also stated that determinism and predictability are not synonymous. So one example of completely randomness is when throwing two dice, the outcome of any particular roll is unpredictable. Now, randomness is measured of uncertainty of an outcome. And one example of real-life predictions is when it is raining and the sun is out, some could predict that there may be a rainbow.
Chaos theory is an interdisciplinary theory stating that within the apparent randomness of chaotic complex systems, there are underlyingly patterns, interconnectedness, constant feedbacks, loops, repetition, self-similarity, fractals, and self-organization. In general, chaos theory deals with things that are impossible or very difficult to control and predict, whether it is an example of something that is nonlinear and actually difficult to predict accurately. Patterns, winds, and geophysical phenomena can change quickly without much notice.
Is related to butterfly effect and chaos theory. Let's take a look at this three-dimensional space, or what we call a free space. We start with three variables that have small differences in initial conditions. At first, we almost see identical patterns with the three variables. However, as it is progressing, we see a slight difference within the three variables. Eventually, it seems that they are already in random motion. Random it may seem, this is still deterministic in a chaotic way. It is deterministic chaos because if you solve the three variables with the same initial conditions any way possible, you will still get the same pattern. A fractional pattern that looks completely random. This is because attractors are very sensitive when it comes to differences, even if it is a thousandths in difference.
To further explain the butterfly effect, we will use phase space and strange attractors. Let us start by defining both of them. Basically, phase space is a multi-dimensional space in which all possible states of a system are represented. One unique point, the phase space represents a possible state. Meanwhile, an attractor is a set of numerical values toward which a system tends to evolve. for a wide variety of starting condition of the system. It can be identified as a strange structure when it can show sensitive depends on initial condition and the fractal structure in the phase space.
Chaos theory in mechanics and mathematics. This study of apparently unpredictable behavior in systems controlled by deterministic laws. It suggests a paradox because it connects two notions that are familiar and commonly regarded as incompatible. Chaos theory has a few important principles. Maybe you already heard this. Butterfly effect introduced by Edward Lorenz, surround of atmospheric predictability. The flap of a butterfly's wings might ultimately cause a tornado. Small causes may have big effects. Initially announced in connection with the problematics of weather prediction, it became eventually a conceit used in very different ambient, some of them outside the strict area of science. Chaos theories help us understand complicated behavior or natural happening studies involve systems. So this has been Nature's Numbers Chapter 8, Do Dice Play God. So this is all for today's video. Thanks for watching.